I am just going to start by saying what we decided last class. So, yay, you guys, it fits with you also. We spent a lot more time last block working on the warm-up and review type problems before we even had a chance to get to the normal CDF stuff with us. So what I ended up deciding to do is they will take their quiz tomorrow during Flex. You guys don't have Flex tomorrow. So what I'm going to do is what I'm going to do is this. You guys are going to take your quiz at the beginning of next class. Okay? You'll have your quiz at the beginning of next class. That means we're not going to finish the entire lesson. So that means the next time I see you guys in Flex, which is not going to be until Monday, I believe is when we have Flex again. Is that correct? Yes, Monday. On Monday, we'll finish the lesson. It just means no flexing out on Monday. Absolutely none. Okay, because you got to be there for the lesson. Trust me, you will want to be here for that. Okay, is Monday 18th? Yes. Is everybody clear on that? That just gives us a little bit more time to work through what we're going and just use Flex wisely. Okay? All right. So let's go ahead and get started on some of these problems. What's important to me here is you guys need to kind of get a little bit more consistent with what work you show. If you just come up with the right answer, hey, Merry Christmas, good for you. You don't get any credit. I have to have some idea of where that number came from. Otherwise, you really don't get any credit. So what do you think I'd expect to see for problem number 1 and 2? A table. I need to see a probability table. So that means for problem 1 and 2, this table basically covers the information I need for both of those. Within that table, you need to define your variable. Okay, that's going to be where our context comes into play over and over and over again. But no, I do not expect to see the actual calculations for expected value and standard deviation. But in order to get that, you needed to show me that you understood what the probability model was. Questions for problem 1 and 2. For problem number 3, we're talking about the restaurant's annual expense for the service contract. What kind of work do you think I'd like to see for that? You could do a table, and in all honesty with this, a table is going to be more work. What's another thing that you could do for this? A what? Write an equation. Write an equation that just tells me what your annual expense was. Even if you did a table for that, you'd have to show me how you calculated those top values. Your probabilities would stay the same. Your top values would change. And so what I would have done, and what I did do, is I made a new equation for my expense, and I went ahead and called that y, just so that I didn't have to keep writing the word expense over and over and over again. And then I calculated the expected value of y and the standard deviation of y. And if you don't want to write standard deviation, you could have done this by saying the variance of y, which would have been the variance of 35 times x, which would have been 35 squared, times the variance, which was 0.749 squared. And then your standard deviation, what I have written here is just the square root of that. So I don't really care which way you did that, as long as I can kind of see what's going into your brains. Brains? No? Weird? Yeah. Yes? That is only going to work sometimes. And that's the problem with standard deviation. That's why I never do any math with standard deviation. Because those rules only sometimes kind of sort of apply. So if you kind of scratch thinking about it in terms of standard deviation and always work with your variance, you should have less to remember and have it apply more often. Okay, Dara, I couldn't tell if you had a question. Yeah, okay. Awful lot of eye contact. No apologies. All right. Now, if I'm talking about a 3-year term, is that 3 times x? It's not. It's not 3 times x. It's x plus x plus x. And that's a very important distinction that you guys need to know. Because the cost for the first year, does it have to be the same as the cost for the second year and the third year? No, they can change. Maybe one year I had repairs, the other year I didn't. And the last year it broke completely. So you need to understand that x1 plus x2 plus x3 is not the same as 3 times x. It works out pretty much the same in expected value, because expected values are super duper nice. You just do what's expected. It feels like it. Okay, good, do it. But for standard deviations do not work that way. I cannot say that the standard deviation for that is going to be 3 times the standard deviation for that. That math does not compute. But you can say that it's 3 of the variances. Because that's the same, that's the same, that's the same. And the definition of multiplication, once you know those are the same, is to multiply. Add becomes multiplication. Standard deviation, square root of that junk. Notice. What am I pointing at? Context. Every single problem has context in it. Labels, descriptors, whatever you need. Questions? For how many of you guys is your work, like what you're showing, matching what I'm asking you to show? Okay, what are you missing? What? Everything? But seriously, what is it? What are you, like for example, for this problem? I would be happy if you went from here to here. Did you do that? What did you do? Okay. So you guys need to understand that's extremely important. Yes. That's fine. If you give me this. You always have to have that. Ladies and gentlemen, taking a second to actually admit what you're missing. Saying it out loud is going to help you keep from doing it again. I need to see this because this is telling me that you know it's x1 plus x2 plus x3, not 3 times x. That's a huge aspect. I need this. I'm happy with this, or 3 times 749 squared. But make sure you give me the standard deviation as your answer and not the variance. Do you think the assumption is reasonable? Well, what assumption do I need? They're independent. Do you think it's reasonable to say from one year to the next the repairs should be independent? It's amazing what I can get you guys to say depending upon how I do inflections on that sentence. Do you think they're independent from year to year? No, they're not. And in so many things in life, things are not independent. You think about it. You buy a refrigerator. My mom would yell at me for saying it that way. Refrigerator. You bought a refrigerator. It breaks the first year. Do you think that affects the likelihood that it'll break again? Yeah, because once something breaks, usually it's more prone to breaking again. It's not going to be, woohoo, I broke it, now it's better than new. That rarely ever happens. So these are just things that you need to consider. And this idea of independence is what all of our statistics is built upon. And if it's not independent, it completely screws up all of our math. Have problems with statistics because they're like, well, all of that was done based on the impression that this is going to happen. Well, what if that doesn't happen? Okay, so 6 and 7. 6, I wanted to see freezer plus fryer, where 7 was fryer minus freezer. or freezer minus fryer because they're looking for the difference. The thing is the expected values, you do what the expect, but variances only ever what? Add. So the variance that I get for this is the same thing as the variance that I get for this. The standard deviation for this is the same as the standard deviation for that. And I wouldn't even expect you to do any additional work for this. Just say standard deviation of fryer minus freezer is 47.83. Yes, sir. Yes, so that I know exactly what kind of a combination you're talking about. I mean, if you wanted to separately, no, you would need to actually do that, sorry. I need to see this initial setup. This setup here. Okay, well the first one, total, is usually an easy one, because total usually means you're adding stuff up, right? This one is saying, which one do you expect to cost more? When I'm asking you for that, like, okay, so how much better did you do on a test than somebody else? That difference, when we're looking for a difference means subtraction. I gotcha. So if you ever see that idea of more or less, they're talking about a difference, and difference always means subtraction. If you defined what A and B were, like if you said, if you had said A equals freezer, B equals fryer, and then did A minus B, perfect, that's fine with me. And then use that same thing for the next one. But if you're using A and B, you have to define which is which. And use capital letters, not lowercase. Okay, that is a big thing though. Capital letters. Good. Yes, because F and F kind of gets confusing. Right. Because the math works out the same. All right? Okay, I'm hoping y'all did your normal distribution review. You actually did it. Oh, dear Lord, yes. Okay. Here we go. Take a look at some of your answers. Now, for number 1, the only thing that I'm missing in the description is for each z-score, you do have to give me a direction. So for I, the student is 1 standard deviation above the average height. For 2, it's 1.5 standard deviations below the average height. So you should always give me directional interpretations for z-scores. And if you look at number 2, I am missing something from my work for A. Do you know what I'm missing? Oh, hail Z-score. Whenever you're doing normal CDF, you must always calculate a z-score for me. Okay? So for number 2A, I would have said 12.5 minus 12.4 divided by 0.2 to calculate the z-score. Always have to show that. Okay? Whether you decide to show me this guy right here, which is the probability statement, or draw a picture, I don't care. Whichever one works for you. But you want to make sure that where you put your numbers here are relative to standard deviations. And it's like kind of scale. All right, here are the other problems. Now the thing with B and C, the 12, 12.2, 12.6, those were all exact standard deviations. So if you chose to use the empirical rule there, that would have been okay. And you can see it's just a tiny bit different than if you were to have used the normal CDF. And everybody falls asleep. At least that is a confuzzled look. Which problem are you worried about? The last one? So you know when we're talking about the middle 50%, that means this box here is, the weight of that is 50%. To be balanced, I have to go out 25 this way and 25 out that way. So from 50, it takes me down to 25% and 75%. Are you okay with that? Then I just do my inverse normal for each of those values. So I did inverse norm, and I did either 0.25 or 0.75, and then 12.4 and 0.2. And that's what gave me those values. Okay, that middle problems, you always want to make sure that you balance that percent. Like a teeter-totter. Teeter-totter. I don't know. All of a sudden, it's like everybody's energy just zapped right out of them. Like one synchronized boop. Goodbye, energy. There you go, Deo. Come on. Come on, bring me back that smile. You got this. Need those giggles, those chuckles, those smiles. All right. We're just practicing the heck out of things today. I want you to focus on what do I need to show. Just giving me an answer, it could be, oh, look, you were very sneaky and were able to look at your neighbor's answer without me noticing. It's a lot harder to do that for the whole entire problem, though. Okay. So all we're doing today is we're kind of talking about example problems, and we're going to tie it all together with a normal curve here. But it really shouldn't sound or feel like anything new, just clarifications. So here's your first problem. Do it, do it, do it. This is not in your notes. When you see it kind of formatted like that, that's a textbook problem. Textbook problems are not in your notes. But I will be working them out with you guys separately. Okay, guys, let's get working, please. So each dozen, yes. The big thing that I'm looking for C, I just wanted to talk about that because there's no real math involved. It's just kind of thinking it through. In order to do these, each carton or each set of dozen eggs, however you want to describe it, it is not each individual egg. That is not the case. It is each carton has to be independent from each other. Do you think that's reasonable? Yeah? How many of you have ever been to a grocery store? Okay, that's a stupid question. How many of you have ever like picked out eggs? When you pick them out, do you like open them up and check them before you buy them? I highly recommend you do that. Okay? You live in life on the edge. There you go. Typically what have happened is if I open one and it's got a broken or a couple broken eggs in it, what's going to happen to the one underneath it? It's probably going to be it's probably going to be affected because how did those eggs break? They were dropped. Something fell on them. It's usually not someone just got angry and chucked the egg into the carton as it was getting done. Guys, might happen. I don't know. Usually done by machines, so probably not an angry machine. But when you're doing that, if you pull one carton out from one stack and you notice that it has a broken egg, you typically go to a different stack. Maybe you don't. It is, guys, what I'm trying to get you to think about here is that it's not a clean-cut type of an answer. But the math that we are doing here depends upon them being independent. Okay? Yes. So we are making that assumption in order to get it done. But with statistics, you always have to go back and think, is that assumption valid? Because all of the math that we do is based on these assumptions, which is why sometimes it doesn't make sense what people come up with. Yeah. You sure? Not all baby chickens are yellow. No. Depends upon the exact breed of chicken. There are black chicks, there are reddish chicks, there are... No, my brother has chickens, so... All right, my brother has chickens. Florida. A lot of people have chickens now. All right, guys, okay. People, come on, please. So this was the work that I ended up showing for mine. And I tried to show minimum work. What would I expect to see you to do? First off, you needed to define your random variable. I had expected value and standard deviation. Even if they say it in the problem, ladies and gentlemen, you must write it down. Yes. Okay, you must write that stuff down. And then I need to see that you did this type of work here, because that is not the same thing as saying 3 x's. That would affect your variance calculations. Those would be completely different. If that was 3x, then the variance would be 3 squared, 0.5 squared. Each one of these can be different. That's what writing it out this way tells us. If I wrote it out this way, that means I'm going to have one value, and I'm going to exactly multiply that value by 3. I'm going to have that exact same value 3 times. This means the values can be different. Okay. How are we doing with this one? Yes. Uh-huh. Well, you have to tell me what that's equal to. Like, when you take the square root of variance, what is that you're finding? Okay? So that's why you need to do that. Okay, anybody else? You're so confused. Where are you so confused? It's not the standard deviation. Do you understand? That's what I'm doing. 3 dozen eggs. 3 cartons of eggs. So that's the x plus x plus x. In order to find the standard deviation, I'm not doing any math with the standard deviation itself. The first thing I do is I take that standard deviation and I use it to find the variance. The variance is that squared, which would be 0.25, which is what I've got written here as that squared. Okay? I just said this is my variance, so to get the standard deviation, I took that value and took the square root. Does that make sense? The relationship between variance and standard deviation? You just saying that to get me to leave you alone? Okay. Okay. All right, we're going to keep doing these, though. Hopefully, if you're still a little hesitant, we will clear that up. Okay. Same general setup, different approach. There are several different ways that you can do this problem. I'm going to do what I think is probably the harder approach. That's one of the ways to do it. That's not saying 0.6%. That's saying out of 12. It's okay. Guys, please. There is an easy way and a hard way to do A and B, and I frankly don't care which one you do. I did it the hard way. I said, okay, now I'm going to define, guys, now I'm going to define y to be the number of good eggs. So if I expect 0.6 to be bad, that would mean I would expect 11.4 to be good. Because how many eggs are there in a dozen? 12. So if 0.6 are bad, 11.4 are good. I'll go over why the standard deviation stays the same in a second. Guys, please. So you can either calculate it as find the number of expected value for good eggs, like I did for the bad, or you can say there are 36 eggs in 3 dozen, minus what you expected to be bad, which still gives you the 34.2 for good eggs. If certain number are bad, then the exact complement of that to get 32 or 36 would be good. Now, B and C kind of go together as to why they're the same thing. Here's my dozen eggs. Of my dozen eggs, I expect about that much, if I were to do it as a proportion, to be bad. You guys right with that? So if that much is bad, that much is good. And when we're talking about standard deviation, we're saying how much should that vary? I expect that line to kind of be somewhere within that box. So if that's the variance for the bad in that box, the good is also in that same sized box. Or you could think about it as this way. No matter what, bad plus good has to equal what? 12. Do you understand where my number 12 is coming from? Because it's a dozen eggs, right? And that means if I didn't want to talk about what what y was, I could think about the number of good eggs to be 12 minus the bad. And if we're thinking about the rules for standard deviation, or actually let's even think of the rules for variance, the variance of 12 minus x, does 12 affect my variance? Okay, no it does not. And variance always adds, so that is the variance of x. Yes? Expected value of bad? That's fine. I understand what you're talking about. The green would be, I expect this many to be good and bad. But that means I could have less, I could have more. And if I have less bad, that means I'm going to have more good. Exactly that same amount. If I have more bad, I'm going to have exactly that same amount less good. Because they balance each other out. So if that means that any way that this wiggles, the other side will wiggle that same amount. It's just a visual way of talking about what this equation does. C was asking, why does it make sense for the standard deviation not to change? And you can either look at it like I did, I tried to explain it the visual way, with no matter what happens with the bad, however much that varies, the good is going to vary by that exact same amount. Or you could talk about it by the actual relationship between the two. And think about it in an equation. Okay? All right, so what we're doing now is we're going to take this idea of expected value. What's another word for expected value? Mean and standard deviation, which also gives you variance. And what we can do is we can take these together and apply them towards continuous random variables, which means it can take on any value within that range, even though, yes, technically you can either have 1 bad egg, 2 bad eggs, or 3 bad eggs, or no bad eggs. You cannot have 0.6 bad eggs. Do you understand what I'm talking about with that? If an egg is partially bad, it's just bad. But in the extreme long run, it tends to look more like a continuous random variable. And for continuous random variables, we are allowed to talk about the normal model because we have mean and standard deviation. The thing about that is if we're talking about the normal model for this, and we're wanting to compare 2 random variables. For example, I want to figure out what your total GPA is by looking at each of your specific classes. Each class is a random variable for the grade. And if I want to combine all of those together, they have to be independent. And what we're starting with now, with this right here, this giving us a condition, this independence condition, is going to be there for everything that we do in this class. Everything that we do in this class from this point on is going to rely on the independence assumption or independence condition. And if it's not, that means all the work that we did doesn't matter at all. Okay, if I'm testing the effectiveness of an SAT prep class and I do a before and after score, but everybody in my class are only the hardest working kids who are going to study 100% of the time, that's not 100% independent. Their before and after schools are tied to that. Randomization helps us get that independence. If you do not have independence, you cannot do this. So no matter what, you always need to think before you get started. Can I even assume they're independent? Or sometimes you're just going to have to say, we're going to assume this is independent for the sake of the problem. Okay? So here we go. This is a very applicable problem because it's something that a lot of people in this country are dealing with right this instant. Go ahead and read that problem. Why do you think I believe this is important to today? California. California right now is going through a heck of a lot of fires. It's destroying thousands and thousands of homes, millions of dollars in property damage. Is every single one of those individuals going to be insured by a completely different company? No. This is important to understand. And actually, this is a great career field, and ladies especially. This is one of those career fields where ladies can get paid more than guys because they so want you. Yep. Welcome to the club. Usually it's the other way around. Okay? And this is what an actuary would do. They analyze this kind of data. If we look at this kind of makes sense. My policy might be like, I might say I have a $200 policy. I pay $200 a year. And so the company expects to make at least $150 from that, to come back in the profit of that. But for one policy, even though my expected value, my annual profit is $150 on one policy, the standard deviation for one policy is $6,000. Why is that possible? Why is that even a consideration? Why is it that big of a difference between the mean and the standard deviation? They insure so many people that allows them to get away with doing this. But why would the standard deviation be so high? Yeah. You're betting on the fact that nothing's going to happen. But when something does happen, I mean, you might be talking about a small kitchen fire. You need to replace the stove. You might be talking about an outlet fire. You need to replace the living room, the kitchen, and the dining room. You could be talking about a natural disaster. You need to replace the whole town. Okay? So the cost of these expenses has a huge variation. You can pay out nothing. Zero. Or you might have to pay for a $2 million home to be replaced. That is a huge spread. Do you understand what I'm talking about with that? That is why the standard deviation can be so big. Even if we were just talking about, well, no matter what, you have a fire, you're going to replace the house. You think about the houses in Prince William, not even Prince William County, Battlefield School District. You're going from townhomes and condos to $1 million homes. That is a huge spread of value. Okay? So what I want you to do, we have here one policy, expected value, and standard deviation. I want you to calculate expected value and standard deviation for 2 policies, and then again, for if you were to have done 10,000 policies. And let's see what happens. Okay? So go ahead and do that work. So here we go. Take a look at it. So the first thing that I did here is I defined that X was the profit on one policy, on a prophecy. Policy. It's a little bit different. Profit and prophecy. I went that way. Anyways, so then the the expected value and the standard deviation. I list those things out. That is a must. You do it once, you don't need to do it again. The first one, we're looking at 2 policies. That's x1 plus x2. You do not write 2 times x, because this and this do not have to be the same thing. So that's $300. The variance ends up being big. The standard deviation is 8,485. So if we look at this, my expected value doubled. My standard deviation increased, but not nearly as much as the expected value did. The way that we write out, because I'm not going to expect you to write there x plus x plus x plus x plus x 10,000 times. Why not? Because I'm not 100% ridiculous. Just like 95. So this is what you do, is you establish a pattern and you say go till. Does that make sense what I've got written here? I'm going to be adding them up till I get to 10,000. So that means I'm going to do 10,000 times 150. So my expected value, if I have 10,000 homes under my policies, I expect to make $1.5 million every year. And that becomes a lot less of a gamble, because that is a huge number. And when I calculate the variances for that, I didn't even bother writing that sucker down because it was like exponential form. I ended up getting $600,000 for my standard deviation. If you want to do the standard deviation equals the square root with all of that, that's perfectly fine. Perfectly fine. Yes, fire insurance specifically. And a lot of times you will actually be purchasing fire insurance, flood insurance separately from a standard home insurance policy. Yes, but if you have 10,000 of them. That's what you expect to make. That's what the standard deviation, because I'm going to probably have some folks that call in a policy. So that's my standard deviation now. So it becomes, what we're looking at here is, guys, expected value versus standard deviation becomes much less of a risk as you get more and more and more policies. Most insurance companies will not just insure thousands of people, they will insure millions of people, which means they usually make big money. But if you have an instance where a whole town goes up in flames, those people are not going to be going, each of them, to a different company. Those companies can go bankrupt if that occurs, which is oftentimes what happens, especially if you're in a smaller group where people do a smaller insurance company. But it's also why things like fire insurance, when you know that you are in a dry area, is an add-on expense. If you're in a flood zone, flood insurance is an add-on, or they might just not insure you for that at all. And you have to be aware of those things because they're aware of it. And they're playing a gamble. And they're trying to decide, do I gamble on you or not? Okay. Still dealing with that same setup. Still talking about the 10,000 policies. Figure out whether or not you think your company is going to be profitable. Huh? No, there has to be a statistical justification for it. It is 100% determinable. If you are profitable, what is going to be true? No, just basic. What does it mean to make a profit? More than you lose. So that means to be profitable, your profit has to be positive. Do you understand what I'm talking about there? So let's see how this works out. I'm talking about this when I'm saying, what is the probability that my profit is bigger than 0? Okay, guys, are you at all kind of focused up here? This is what I expect to make. This is my expected profit for 10,000 policies. This is my standard deviation for those policies. The probability that the profit is greater than 0. If I'm going to be calculating probability, what should I start with? Z-score. Because if you're going to be doing the normal CDF, you need to start with Z-score. Because sometimes we can finish with Z-scores. So I can calculate my Z-score by saying value, which is 0, minus expected, over standard deviation. And that guy ends up actually being, I had done the math on that, what was that? Negative 2.5. If I were to talk about this visually, how much do I expect to make? So I'm just going to say 1.5 million. And if the standard deviation is 6,000 or 600,000, this would be 0.9 million, that would be 0.3 million, that would be negative 0.3. And so being profitable, that's $0. Do you understand what I'm talking about? And profitable is any of this over here. Is the company likely to be profitable? Yes, there's a very good chance. And so we would say yes. And you can either say because a Z-score equal to negative 0.25 is going to be unlikely to occur. Or you could even calculate that probability using what? Is it inverse or normal? I'm giving you a value. I'm looking for a proportion. That's normal CDF. So I would go normal CDF. What would my lower be? What would my upper be? And you got to be really ridiculous here because we're talking 1.5 million. Do you understand how much that's important? What is my expected value? 1, 2, 3. Too many stupid zeros. So you know what? Let's make life even easier. Let's just go crazy nines. Let's do this in terms of millions. So 1.5 million, that would be 0.6. So I have a 99.37% chance of being profitable. Actuaries make a lot of money. Yes. I could not do that job. Yes, they sit in an office all day long and they don't really talk to anybody. Yes. Yeah, and that's what they're talking about here, is this is continuing off of what we were talking about before. If you have 10,000, it's very likely to be profitable. If you only have one, not very likely. You're like barely a 50-50 chance. Right. Okay, so this was saying, if the company sells 10,000 policies, then the profit of 0 is 2.5 standard deviations below. That's unlikely. But if we sell fewer policies, if we go back and we look at what the different values were here, if I sold one policy, standard deviation, I quickly get to the point where I can lose everything. The more policies that I have, so 2 was a little bit better, 10,000 was significantly better. The more policies you make, the more likely you are to make money. All right, let's switch context here. Dogs and cats. What do you think I would expect you to start by doing? Labeling, listing them out? Like X equals, Y equals, identifying your variables. That is going to be your first step. And ladies and gentlemen, I'm not just kind of trying to make your life difficult here. This is what you need to do. Start it off by talking about what they give me. I don't care. This part right here is optional. If you want to define what order your difference is, and just call that difference D, you can. So you could say the expected value of the difference. Or if you don't define it there, you do have to define it here. You have to say what it is someplace. The way I did dogs minus cats. So -20 would mean I expect which one to be more expensive. Cats. I expect the cats are going to be more expensive, which is weird. I don't agree with that. Dogs are bigger in general, and therefore they cost more. Yeah, I guess. And then the standard deviation. Even though it says subtraction, with the variance, what do? Variance always adds. Yes. It does not matter if you do X minus Y or Y minus X, but you need to indicate, because for the problems that come next, you have to remember which way you did it, because then it affects how you finish it. Yeah. That's fine. I'm just in the mode of doing X's and Y's. Okay, so using this idea, apply that to the normal model. Come on. Yes, you know how to do this. This is exactly like what we just did with the fire policies. If you want to think this through together, if the cost for the dog is higher than the cost for the cat, what does that translate into? You expect the difference to be, it depends upon which order you put it in. If you put X minus Y or dogs minus cats versus cats minus dogs, you're going to be talking about either greater than 0 or less than 0. So you either did x minus y or y minus x. Depending upon which one is your cats and which one's your dogs, you want that difference to be greater than 0 or less than 0. It depends upon which order you put it in. Okay, so let's take a look at how this works out. Again, there are a couple of different ways that you can do this. It all depends upon which order did you define your difference to be. Since previously I had done my difference to be x minus y, dogs minus cats, if the dogs are going to be more expensive than the cats, then that means that this difference should be greater than 0. If you did cats minus dogs, you should have less than 0. If you did cats minus dogs, that would have been a positive number. Okay? And that would have changed whether or not your z-score is positive or negative, but the number should have been the same. And your probability that the dogs are more expensive is 0.3322, or 33.22%. Deo, what's that look for? Do you know where I got that number from? I did dogs minus cats. And if dogs are more expensive, if that's the bigger number, I'm looking at greater than 0. Okay? If I did cats minus dogs, that means the dogs would be the negative, so that would be less than 0. Yes, ma'am? The reason why did you do cats minus dogs or dogs minus cats? You did what I did. Okay, then what you need to make sure that you're doing here is for your normal CDF, your lower is going to be 0. Greater than, because if the dogs are more expensive, then the first number is the bigger of the two, which would result in a positive number. The question just said, what's the probability that the dog is more expensive, the cost for the dog is higher than the cat? But it depends upon which order you put that in as to whether that's going to be a greater than or a less than symbol. Yes? Okay, guys, I'm not going to give you any more homework, but just know that your quiz is going to be the start of next class.